Today I'm going to discuss the embedded system engineering roadmap. So what we are going to do in today's live stream, we will be exploring the job posting on LinkedIn, Indeed, so we can figure out what the industry is looking for while posting a job. The best thing about the embedded system engineering field is that the requirements don't change very often. Because this is an engineering field, things are pretty steady. Rather than if you go to the web development, the technology is changing every day. So if you work on some JavaScript framework, it may be chance that overnight a new framework came and the hype caused change, and there is very less stability on other development fields. But in the embedded systems development, the things are pretty steady. So if you work on assembly language, the Verilog, the C++, the same things will be applied on to your throughout career. So the main programming languages that you may be required on your day-to-day job is assembly language programming, and after that C++, C, embedded C, C++, and nowadays MATLAB and Python are also required for some kind of embedded Python. The reason the Python is being popular is due to various microcontrollers are capable of running the Python on board. And the reason for using the MATLAB is that you would be able to use the MATLAB for doing a different kind of simulations if you are in some aeronautics or in some advanced level fields. So you may need the MATLAB as well. So let's get started and see what we can achieve. We will identify the embedded system roles, responsibilities, the job requirements, tools and technologies to learn, and we'll finally create a basic roadmap. So first of all, let's discuss the core embedded systems and firmware roles. We will enlist what kind of embedded systems roles are available in the job field. So if we open up some job portal like the indeed.com, and let me just switch so here you can see there is embedded software engineer. So this is the very first and very most common job role in the embedded system field that you may see. It is similar to embedded engineer. Then we have embedded firmware developer, and if you look for the job description of embedded firmware developer, here you will see develop and optimize firmware for range of microcontrollers. So the basic is to write a firmware for the microcontrollers, and you also need to collaborate the cross-functional team to drive technical decisions and resolve complex challenges. And this company is using the NXP microcontroller, the microchip, Atmega, ATSAM, and LAN. So they drive the integration of firmware with embedded Linux. So there is one more requirement is embedded Linux and OpenWRT platforms. So the Linux knowledge is very important in embedded system fields. You get stuck in somewhere where you are creating some advanced embedded system product where you need to use the Linux. So the Linux became mandatory and you need to use the Linux. So you left the option with some kind of Raspberry Pi. If you're aware of the Arduino Yan, it uses the OpenWRT. and I have a video about the Arduino Yan. Actually that was the first video on my YouTube channel, the configuration of the Wi-Fi of the Arduino Yan. You may check out. Utilize the FPGA technology. They are actually asking too much, so yes, you may need to work on different platforms. It is very common. So I personally believe that you should separate the FPGA developers from the microcontroller development, because if you put a lot of load on your single developer about the FPGA, other development like STM32, EXP, NXP, Arduino, Microchip PIC, and other microcontrollers, you don't have to switch from a language a lot of the language barrier. But if you come to the FPGA, the hardware descriptive language and the Verilog is very different. So you have to change the mindset. You have to switch your digital circuit designing techniques, and you have to switch from a normal paradigm of sequential programming to multiple concurrent processing and the digital logic designing work. Well, you could get a chance to work if you have a product where you are only working on a simple FPGA for a month, or your regular work is one product, so it is good. So if this DOS solution is looking for the embedded firmware developer because they need a FPGA developer for current work, but they want to open they may be required a developer for microcontrollers and FPGA, but they are working on one product at a time, so it is pretty good idea, no doubt on that. So contribute to embedded Linux development projects, particularly with the OpenWRT. So basically what this company is doing, they are heavily based on OpenWRT, or they have some product in line which works on OpenWRT and embedded Linux. So they need a developer that can be useful for the Linux as well. Then they have implementation and automated testing platforms and unit test. The unit testing in throughout my career for the embedded systems is very low. When you work for a bigger product which have a lot of code, then you need to do the unit testing. It is very important, because when you go out and new developer come and he writes some code and breaks the code, so unit testing will always help. The automated tested experience in the real-time operating system, it is a must for nowadays. The RTOS is very important in the embedded system roles. So whenever you are doing an embedded system role, the RTOS is very, very important. We'll look into the job requirements from the US as well, and you will see that the RTOS is very basic requirement in the job. Design and implement firmware solutions for various embedded application and devices. Yes, this is pretty common. Work closely with hardware engineer to integrate firmware with the hardware components. Yes, this is also important. You have to, if you are a developer, you need to work closely with the hardware engineer. So you are a firmware developer and you have a hardware engineering team. So you need to work with them, and you need to integrate your firmware with that hardware components, and perform throughout testing and debugging of the firmware and ensure reliability and performance. And yes, you have to test your code, and you need to be sure that it is okay to work in an industrial environment. So industrial product is another thing, and if you are just doing for it a hobby project, it is very different thing. Believe me, I had worked on some products which is working pretty fine in table testing, but when you apply that embedded system product in actual field, lot of interference from external environment occur, and the microcontroller gets stuck if where you need to put an watchdog timer, or there are chances that some other real-time factors are affecting your code. So yes, you need to perform thorough testing, and you may need to do a debugging. Debugging and troubleshooting skills are very important for every developer. If you are working in any kind of development field, the debugging is a crucial skill to learn. So you should focus on more on debugging tasks. You should spend more time on debugging. So remember that you should learn the debugging techniques. It is a very important skill. Next, where we go. Let's look into the senior C++ embedded firmware development. And when you come to the senior roles, the senior roles, it also depends on the kind of skills, but when a company is looking for a senior developer, it mainly looking for a person who can handle a project from start to finish product. So when you become a senior the embedded system, rather than other development projects like a web development, where you are creating a web application or a mobile application for a mobile developer, the reason for our team is that it is based on various individual small tasks. So there is a different team members who collaborate and do a complete project. But sometimes, actually the most of time in embedded systems, individual person develop a product due to the reasons the product is small in nature, or our code is very small. But sometimes the product is very big, and you need to focus on a crucial tasks. So you split the task from different you have a hardware team which work for the PCB designing. There is a PCB designer, there is a PCB manufacturer, there is a PCB assembler, there is a hardware tester, then there is a firmware developer. So these are the team members where you need to collaborate. And this is we were okay. The vast experience in embedded firmware and microcontroller, these are pretty similar and same skills. And the requirements list, if you come where experience with the STM32, ESP32, ESF, ESP, IDF mainly. STM32 is pretty industrial standard, but in my experience ESP32 is not. I have faced very much issues, although there are various products developed with the ESP32 which are working pretty fine in the actual field, but I have faces the issues where I think that ESP32 is not ready for certain tasks in industrial environment. This also comes to another topic, which I want to discuss today. And this is that when you work in embedded system field, there are some specific roles which are very specific to industry domains. So you need to work on that specialized roles. There are embedded system architect, which designs the overall architecture of embedded systems, including hardware and software components. There is real-time embedded system engineer, which is specialized in systems with strict timing constraints, such as the control systems or robotics. So if you are going for a job which work for some control system or in a robotics field, you may need an experience in your development where you work a lot of time with the real-time systems. So there is an embedded system test engineer, which focus on testing the embedded systems and ensure that it meets the performance, reliability, and safety standards. There is also a system hardware engineer, which works closely with the firmware engineer and design the hardware components for the of the embedded systems. And there is also some related roles like IoT engineer, which develops the embedded system for IoT devices. This IoT engineer must have an experience with the web development, the REST API, the MQTT protocols, and so on. The automotive embedded system engineer. So these are the fields which we need to be discussing. And let me zoom in. For that, the automotive embedded system engineer, it works on embedded systems for the vehicles. So if you are going for a company which works with the vehicles, including the engine control, the infotainment, and the driver assistance systems, it is very much focused on user safety. You are working for a vehicle, so you have to create a product for the vehicle which do not get stuck. There are some dedicated microcontrollers which are specifically designed for automotive embedded systems. I remember the STM8 have a special dedicated family. It is called the STM32A series, which is specifically for the automotive systems. And there is also a CAN bus protocol which is widely used, and if you are going for an automotive embedded system engineer, you should be well aware with the CAN bus protocol. Although the various communication protocols and the bus systems are required for you to be an embedded system developer, but for the automotive embedded system, it is very much important and it is a crucial skill that you know the CAN bus protocol, because it is an ISO standard protocol, and all the automotive systems use that bus. There is other special field, which is embedded device medical device engineer. So if you are working in company which create embedded system products for medical systems, like I created one product for baby care systems, where a newborn babies are put and given different lights. I didn't actually remember what that machine is called, but there are a lot of medical protocols which have to be followed. So that medical person provide me the standards that it should follow that, and we developed a product. So basically what my role was in that product development was that I have to create a embedded system with the device which change the light intensity. So I have just done that with a simple PWM. But yes, if you are developing embedded system for medical devices, you need to require understanding of safety and regularity standards. But if you get stuck where you don't have some specific training, but your company decide to work on a medical device systems, or create a product for a customer for a medical standard, then you should ask for their regulatory standards. Okay. This come into my mind one more embedded system product, which is a nurse call system, which is put in a medical environment in the hospitals, where the patients call the nurse if they are in need. So they press a bell, and there is a international standard product already available and used in the hospitals, which is a CTEC, I think, or a similar product. But the reason for you to develop it, I had developed with the Node MCU to making it a wireless. And I learned that in hospital environment the wireless systems should not be used. If you use poor engineering, if you develop a product which is poor and you put that in actual medical systems, in the hospitals, it may interfere with the real machinery, they are monitoring the patient vitals, with the live patient monitoring systems, and your device could interfere with them. So if you are developing a product for a medical systems, you may consider a total separate wiring. You should consider shielding properly. So you should not you should focus that your product do not interfere with the actual medical devices which are used on patients. So if you are creating a device which have to be used on patients, you need a lot of licensing. In Pakistan, I'm sure there must be other countries are also following the same protocols, and you also need the licensing for creating some medical product which finally get used on actual patients. Moving forward, aerospace embedded system engineer, they work on embedded system for aircrafts and spacecrafts. They focus on reliability and performance in extreme condition. The aerospace embedded system engineer, they are you have to be master in aircraft controls. You have to be master in control systems. The PID control is very much work on a drones, and you need to be know how to drive the motors, the actuators, the sensors. You need to be focused on performance, reliability. So these are the standards if you are working from some aerospace medical system engineer. There is also one more role, and if you are working for some let me you need to know some protocols also. You also need to identify if you are working for a consumer electronics products or industrial products. These have total different domains. Although the embedded systems is very vast field, and sometimes you may have to deal with one or two or many products from different domains, and you have to work on all of them. So maybe your company will decide to create a product for automotives, and then medical, then industrial, then consumer, or maybe you are working in a big company who are dealing with a lot of products, like I work in Hall Road, and they work in mostly on consumer electronics products, but sometimes a lot of times we have to deal with the industrial equipments, industrial products, like products which monitor a running machinery, and they need to display the number of hours the machine had worked, and other kind of stuffs. So there are also times where we need to create a product for some medical systems, like I had mentioned for baby care system. Although the company was a different which manufacture actual medical systems, so they have a proper licensing and all, but they give outsource PWM generation task. So you may have to work with some robotics for maybe a hobby, because in Pakistan the robotics are not deployed as far as I know, but if they are working, I'm not aware of that. So you maybe have to work with robotics as a hobby. You have to work with the control systems. You need to know the communication protocols like CAN, Ethernet, USB, Bluetooth, and Wi-Fi. The communication protocols are very important nowadays, because the IoT is taking over, and most of the devices are becoming the IoT, and you need to learn to transfer the sensor readings to our remote locations for a monitor who is monitoring the parameters maybe on the mobile or in a laptop or on a website or on a Wi-Fi, Ethernet, or it should be an options. Maybe you have some hardware which need to provide some sensor data to a computer, and you created a computer desktop application, so maybe you need a USB protocol. The microcontrollers like the STM32 have built-in USB port which you can use as a CDC, or you can use it as an human interface device which is called the HID. So you need to know how to use. I recommend using the STM32 because it gives a variety. But if your background is from microchip PIC, and you can go for PIC 18, there are pretty good numbers of PIC 18 which supports the USB as well. Moving forward, I assume that the streaming is not good on this OBS Studio. I'm just trying the OBS Studio for streaming, but I think it is not working good. I will try to wrap up things. So yeah, you should be aware of specific domain knowledge, like if you want to work with the automotive, how they work, aerospace, how they work, medical, how they work, industrial automation, etc., and consumer electronics as well. And if you are working with the IoT, you should be aware that the IoT protocols, cloud integrations, and data analytics, MQTT, and other REST APIs, etc. You should be aware with some kind of web development as well. And embedded Linux. This is a very important skill to know. Embedded Linux, it is, embedded Linux is you need to know the kernel internals, how to create a device driver, how the file system works, the network stacks, what is a network stack, etc. I recommend using a Raspberry Pi for this. If you want to learn the Linux, you should work with the Raspberry Pi. I prefer Raspberry Pi for the Linux learning, or you can use some simulators and work on that. You should also stay updated with the technology trends. You should attend conferences if are available on your area, or any webinars or online webinars. You should take them so you can get updated. Although the technology don't change very much, but if there is a change, you should be aware of that. How I personally keep myself updated, I explore the different areas. Okay, so how I do update myself, I look on different job postings and some freelancing like Upwork, and what kind of problems people are posting. Although even if I don't work with them, I just look into the requirements, what kind of requirements the user are posting, and also the official websites like the Microchip and Microchip have a pretty much the application notes, and I try to keep myself up to date with the application notes, with the microchip, and what kind of microcontrollers they are building, and what kind of tools they are creating, and what kind of products they are making, what kind of boards are available in the market. So I used to purchase a lot of different boards. Some of the boards I never used, but I just purchased and look what they are, how they works, and maybe just you know, the hello world program, etc. Okay, coming back, bachelor's degree in electrical engineering or equivalent, this could be an computer science degree should also work, because in my case I have a computer science bachelor's degree, and I had done the associate engineering diploma in electronics. That's how I come into embedded systems field. And proficiency in embedded C and C++ programming. You will see the C language is a must, because the C language and C++ is a major language for embedded systems, and that's why you should be aware with C and C++ concepts like the pointers and other things. I'll create a separate video on that, and I'll let you know the basic concept and specifically the pointers, and I maybe the next stream would be on C++, so stay tuned, and don't forget to subscribe or and RTOS. So coming on a roadmap, what should be a roadmap? If you are just getting started, I will say that you should learn basic C on a programming site, and you should buy one microcontroller. You can choose any microcontroller of your choice. Go to your electronics market, research what kind of microcontrollers you can find. If you want to start with the AVR or the Arduino, which is widely available, you should learn from the data sheet. Always start with the data sheet. Learning to read the data sheet is very important skill which any electronics or embedded system engineer should be aware of. So you should also go with for the reference manuals, the data sheets. You get comfortable reading them, and then don't just jump into start creating, because if you just start creating and making projects, maybe you have heard a lot of online mentors telling you to start building the projects and get used to it, get stuck somewhere, solve the problem, and that's how you move on. This is also one of the approach. You can go that route, but I prefer not to. Start slowly. Start with the getting comfortable with the data sheet. Start with the assembling some hardware with basic electronics, digital electronics, the basic LED blinking, how the GPIOs works, and then the C concepts, what the loops are, what the conditions are, what the pointers are, how the memory reference works. So these kind of concepts, because if you go with this route, it is a long sustaining route. If you go start building the projects, you will be a copy paster. Although in a programming we do a lot of copy pasting, but it will lack you the basics. When you get stuck and you don't have anyone to help you out, you will not be able to get out of that deadlock. But if you prefer to read the datasheet, to learn the basic programming concepts, and get your hand dirty with your strong foundations, then you can choose the route of building the projects. In that way, whenever you get stuck and you don't find any help, you will figure out how to get out of that deadlock. So strong understanding of motor, sensors, servo, stepper, motor theory. This is also a basic concepts. If you are going with industrial automation, you may also need to go the route with the PLC and HMIs. Lot of industries work with the HMIs and PLCs. So if you are going to choose the PLCs and HMIs, these are the total separate route. So you can choose that as well if you know that you will only be focusing with industrial automation. If you are only focusing the industrial automation, you should start with the PLC and SCADA systems and the HMIs. And that learning curve is a little bit of expensive because the equipments are expensive and you get very little chance to implement some logics in real worlds. So if you have some small industry, maybe a poultry farm, some of your friends having, and you want to automate that poultry farm, just go and ask and offer your services. And any other industry, very small industry, go for them and see what you can do for them. But it is a risk. Don't forget to take safety measures. Don't it is very get very dangerous if you start without the safety measures. You should be focusing on safety measures first. So that's how you can start. You should start with the microcontrollers, C programming, the I2C, SPI, CAN bus protocol, RS232, RS485 protocols. Then you should move with some display interfaces. You can start with the HMIs, the TFT, the 7-segment, the I2C, the LCD. Then you can jump for interfacing other peripherals like sensors interfacing. You can interface the temperature sensor, the humidity sensor, the smoke sensor, the MPU sensor, which is a gyroscope, accelerometers, and then you can interface the motors. You can combine the systems and then explore others project, others code. Go to the GitHub, learn the GitHub, and it is also a very crucial skill for a reputed company. Whenever you go with some big companies, they require you to know the Git and the GitHub. So learn that skills. If you have any question or I forgot to add something, just leave a comment. I need to end the stream. I don't know how good the stream was. So that's all for today's stream, and thank you so much. See you in the next one.